All right, welcome to this PowerPoint on waste incineration for AP Environmental Science. So this is the one energy source that we're going to talk about without any learning objectives, but you should know it regardless and be able to discuss it on an FRQ or something like that. Therefore, it's going to be hopefully a pretty short PowerPoint. Here's the vocab, but I'm going to skip it. It's only two words anyway. Well, two terms, that is. All right, so waste incineration. When we're talking about this, we're going to talk about it in terms of creating electricity, but you can burn waste for any reason. A lot of that is just to get rid of waste. It might be to extract something from the waste so you can burn the insulation off of copper wires to get to the copper inside. But when we're talking about it, we're just going to talk about it in terms of producing electricity. Now, what do I mean by waste? I mean trash. So solid municipal waste is what we're incinerating here. And we're going to essentially burn it in a facility that is very much like a coal burning power plant, where it's going to have the same components of that power plant. We'll get to that on the next slide. It provides a consistent energy supply. This is considered renewable, but I'm going to say that's non-renewable because we should be transitioning to a zero waste economy anyway, or a circular economy anyway, where there is no large scale production of lots and lots of municipal waste. So I'm going to say it's non-renewable. I don't expect that you would ever see an AP question asking whether this one is renewable or non-renewable. If you think about like the waste stream and the amount of trash that we create all the time, yeah, we could keep burning the trash that we produce, but should we really be producing all that trash and sending it to a waste incineration plant instead of recycling the various components and reducing waste in general and creating more of a circular economy? I would argue that it is non-renewable. So what you do is you separate your waste and you get anything that can combust. That could be any type of paper, cardboard, any type of wood product. It can be any type of anything from biomass as long as it's dry enough. It could be plastics. It could be hazardous waste, so like the plastics coming from hospitals. And we're going to take all of that and we're going to take it to basically a power plant, just like a coal burning power plant. And we're going to send it into the furnace. The furnace is going to have the pipes in it that have the water that can boil and turn to steam. That steam is going to turn a turbine, which is going to power a generator, which makes electricity. So very similar to many of the other ones that we've discussed so far. So this is what a diagram of it looks like. We can have our municipal waste, and that municipal waste we can do the 3 R's and reduce anything, reduce the use of things and eliminate trash, or at least reduce the use of trash, reuse many things, recycle many things. But what can't be, or what they decide should instead go to an incineration plant, will be sent there. It will typically be dried, shredded, combusted, and inside the combustion chamber or the furnace, you're going to have the pipes that have the water, which is going to turn to steam, and that steam is going to power a turbine, which powers a generator, which generates electricity. There's a lot of other stuff that you see here, like fly ash and any of the bottom ash and all of that. We don't really need to worry about it, but we are going to produce a lot of ash in this process. That ash can be refined into its metal constituents. It can be used as aggregates, so you can use this as a filler in cement or concrete. Maybe the asphalt that you put on roads, you can use it as a filler for something that's like gritty and solid and rocky. You can use that aggregate. Anything that can't be used for any of those other reasons will end up going as ash to the landfill, where it will be landfilled. So there are some benefits of incinerating waste as opposed to just sending all of it to the landfill. And I'm not going to go into the materials that should be reused and recycled, which we'll talk about on another day. Let's just say that the options right now are landfill or incineration, and not think about recycling for a second. It can reduce landfill mass by 80 to 85% and the volume by 90 to 95%. If you're taking all of this material and you're combusting it, all that you're going to be ending up sending to the landfill is the unusable ash and clinkers and cinders and stuff like that. The aggregates, some of the clinkers, some of the cinders, some of the metals can be recovered and recycled and reused. So a lot of this stuff can end up not going into a landfill. Much of it is going to go into the atmosphere as atmospheric pollutants. That would be carbon dioxide, carbon monoxide, nitrous oxide, sulfur dioxide, particulate matter, all of that stuff that we've talked about with the other energy resources. When you burn this, it is a very dirty burning energy resource, which we'll talk about in a little bit. So a lot of stuff is going in the atmosphere, but in terms of just reducing landfill waste, it can reduce it by a very large margin. This can be especially seductive to a small nation, a nation that doesn't have a lot of land surface anyway, in order to landfill. So let's think about like a small Pacific island. They need their own electricity supply, and if they have a power plant that can burn their waste, then they may opt for that rather than creating a landfill, which would grow and grow and grow as you burn, or sorry, as you landfill more and more trash. So island nations, any nation with small land area, may find this as an attractive energy source rather than landfilling. What the drawbacks? I said before that we would ignore reducing and reusing and recycling for a little bit, but in reality, we should reduce our consumption. We are a hyper-consumptive economy and culture in the United States, and we shouldn't be consuming so much because um, that would put less of a strain on all environmental systems. Anything that we do use and has reached the end of its life should be destined for other places than a waste incineration plant or a landfill. It should be composted if it's organic matter. Composting would be way better than waste incineration for any of our organic remains or trash because it would return nutrients to the soil and it would avoid most of the carbon from going into the atmosphere. Compost is a carbon sink rather than a net carbon source. So that would be much better. Recycling, reusing, definitely better than combusting in the first place, because if you recycle something again and again and again, you don't have to mine or otherwise extract or refine new materials. You can just use those same materials over and over through the recycling process. Okay. And again, we should be moving to an economy that doesn't see things as a single stream economy from manufacturer to consumer to landfill or wherever it is destined for end of life. It should be more of a circular economy where it goes from manufacturer to consumer to recycling back to manufacturer, consumer, etc. Pollution levels are definitely going to vary based off of local regulations, but you can see that they can be very severe, like on the top right. Because we're burning so many things that are so varied in their composition, we can be burning just about anything. And we're going to release a lot of heavy metals. We're going to release nitrous and sulfur oxides, carbon dioxide. We're going to release a lot of dioxins from this activity, which we'll talk about on another day, and lots of particulate matter. And many of those can be noxious noxious gases or toxic, especially many of the dioxins that are coming off of plastics. And we'll talk about some of the ways that we can mitigate that air pollution later on in our air pollution unit, where we'll talk about bag filters and electrostatic precipitators, etc. In terms of how much waste incineration we are doing worldwide for energy production, it's less than 1% of the global energy market. It sometimes is economically viable, not always, since it does take a long time to recover investment costs. But if you convert an old coal burning power plant to a waste incineration power plant, that may be more of a cost-effective process rather than building a new one from scratch. Usually you're going to see these in impoverished or otherwise marginalized neighborhoods because of all of the air pollution that's associated with them. So there is definitely human rights and socioeconomic problems with it as well. And Europe is going to lead the world economies right now with 450 waste to energy plants or waste incineration plants, which burns 25% of the continent's waste. And in fact, Sweden is a net importer of waste from other countries for incineration, and it's illegal to actually send combustible waste into Swedish landfills. So some countries are definitely embracing waste incineration, and other countries are a little bit more reluctant. And that really boils down to two things. One is the land use problem that we talked about before. If a country has lots of land, like the US or Russia, they're probably more likely going to landfill waste. But if you're a small European country that doesn't have a lot of land surface and needs every square mile of it, you're not going to landfill as much. You're going to see waste incineration as a better option. It's also considered a transitional energy source. So it's used to transition economies off of fossil fuels into eventual 100% renewable energy sources. There is a lot of problems with that. There's a lot of greenwashing and clever accounting that takes into account carbon dioxide emissions. And most of the waste incineration plants are going to be labeled as carbon neutral because it is very recent carbon. In some cases, like with paper and cardboard that we're combusting, right, that carbon was in the atmosphere 10, 50, 100 years ago, drawn down via photosynthesis, incorporated in biomass, and then burned, and then you send it back into the atmosphere as carbon dioxide. But a lot of it is plastics that people are burning, and those plastics are refined from crude oil, and those carbon molecules that are in plastics that were refined from crude oil were locked in the geology of the earth for tens or hundreds of millions of years and have not been in atmospheric circulation. So if you're burning plastic, that is a net source of carbon dioxide into the atmosphere. It increases the quantity of carbon dioxide in the atmosphere. Okay, so we do see it as a transitional energy source. Some people are very pro waste incineration. Some people are very anti waste incineration. I've seen environmentalists even that are very pro waste incineration in order to get economies off of coal, but then other environmentalists that say that you would have to be insane to do a waste incineration plant due to the level of atmospheric pollution that it produces. So just to wrap this up, one more slide about the human health concerns. We are combusting, like I've said, any type of material that will combust. That could be synthetic rubber, like in tires. That could be treated lumber that has heavy metals in it. The synthetic rubbers typically have heavy metals. It could be hospital waste that has different radioactive materials in it. It could be any type of plastic that is going to release lots of different types of dioxins into the atmosphere. And the human health concerns are really going to depend on the local regulations and how much pollution actually gets into the atmosphere and what protocols the power plant puts in effect to reduce pollutants. But they can range anywhere from respiratory issues like asthma, bronchitis, the exacerbation of pre-existing issues like emphysema or asthma. You can have cancers, reproductive dysfunction, birth defects, all of that stuff. We'll talk about all of that, especially within the context of dioxins and heavy metals in our atmospheric pollutant and aquatic and terrestrial pollution unit. So I'll hold off on that for now. And then the death rates are 0.04 to 1 deaths per terawatt hour, which isn't the highest among our energy sources by any means. That is definitely still going to be coal, followed by oil, biomass, and then natural gas. But this lags not too far behind natural gas. Anyway, I hope you guys learned something. I'll see you all in class. Bye.